Hi, and welcome to harness the full potential of IoT data with AWS IoT and Analytics Services. My name is Tom McMeekin, Solutions Architect, and I hope you're having an amazing summit online. Today we'll be exploring the core ingredients to unlocking that full value of IoT data. We'll also be diving deep into an industrial use case and exploring how AWS IoT Sitewise can accelerate your time to value for industrial IoT use cases. This is a 300 level session and assumes some knowledge of the AWS IoT services. When I think about IoT, I think about three core capabilities. The first, I think about devices, where according to industry analysts, we had over 26 billion devices come online last year, with a further prediction of 75 billion devices being online by the end of 2025. The second thing I think about is about the data that's being generated by those devices. Now, IDC predicts a staggering 80 zettabytes of data being generated by those devices at the end of 2025 alone. And the last core component I think about, and to me it's the really exciting aspect and really meaningful part of IoT, is the transformational outcomes being driven from that data being generated by those connected devices. So today you might be thinking about putting IoT into your operations, or you might be thinking about putting IoT directly into your products. But the key thing I want you to think about is about the problem you're looking to solve. And that's where I want to start with today, and ask yourself to spend a second or two to cast your mind across the industry that you represent and ask yourself this. If you knew the state of everything and could reason on top of that data, then what problem would you solve? So say for example, if we regroup and think about the consumer retail experience, today it's a really an exciting and interesting space to see some of the new ways companies are servicing customers. A lot of these new customer offerings are being driven by the data being generated and flowing throughout the business. Now, data is foundational to this, allowing companies to get closer to the customer from supply chains all the way to consumers interacting with products and services. Now, IoT plays a key role in enabling this, enabling interactions to be captured right at the edge and process automation to also take place there. Now, as leadership teams start to think about real-time supply chains and optimizing for customers and providing more personalized experience to those customers, today what we're going to showcase to you, the builders, is design principles and best practices for building an IoT analytics platform on AWS. But before we dig into that last point, I want to spend a brief moment giving you some perspective on what other customers are doing to solve with IoT. We see IoT being applied across various different use cases. From a predictive maintenance perspective, companies are using IoT and data to optimize the production and maintenance in a way that they have never been able to do in the past. From a health perspective, health organizations are now able to monitor lifestyle routines of patients at home without intruding on their personal privacy. And from a workplace safety perspective, enabling companies to embed automated safety solutions to detect and prevent accidents of their staff out in the field. So before we understand how to harness the full potential of IoT data, I'd like to first cover at a high level the three core ingredients and fundamentals to IoT. The T in IoT, of course, stands for the thing and is the most crucial component to any IoT project. From the thing perspective, you need software that you can put on those devices and that you can build and operate them at the edge so that it can communicate to the cloud. Then you need services to enable the cloud connectivity of those devices. And the most important fundamental here is connectivity at scale. Managing fleets of devices and keeping those fleets healthy at scale and secure is critically important. Last but not least, it's all about the data that's being generated, so you can make sense of that data and make decisions to improve on your business. But the most important thing here I want you to think about is treating this as a circle, where the devices send data via control and connectivity services into the cloud, where you can then use analytical services to gain insights of that data, take actions, and then you can bring those actions back to the physical world and possibly to those devices. So you can think of this more like a virtuous cycle, which is rolling all the time and gives you the intelligence and outcome that you need to drive your business. Now, AWS provides different types of services and software across all these three areas. So let's take a look at this. So starting from the devices perspective, the typical question that I hear from customers is, how can I build those devices and operate them at the edge, but also work with the cloud? Or how can I get cloud capabilities working locally for applications running on devices where there is intermittent or even no connectivity? And for these questions, we have different software offerings for different use cases, as IoT is complex and it can span across from small sensors running microcontrollers, for which we have Amazon FreeRTOS, which provides you AWS-specific libraries that you can run on top of the FreeRTOS kernel, and to big edge gateway services or devices running powerful applications such as in factories or industrial locations where you can run AWS IoT Greengrass to bring the cloud paradigm to the edge. Now on the server side, the typical question I get asked by customers is, how do I securely connect my devices to the cloud and manage them at scale? Now AWS provides 3 services here to assist: IoT Core for connectivity and data management, IoT Device Management for managing large fleets, and then Device Defender for providing audit capabilities of your device fleets and running these at scale. And finally, AWS provides 4 different types of AWS Analytics services to help unlock the value of your IoT data. We have IoT Analytics, which is specifically targeted for IoT type data, as IoT data is intrinsically different from typical BI data and is typically unstructured or binary. So AWS IoT Analytics helps you do a lot of the pre-work before you hand the data downstream for further analysis. Then if you have a complex business logic where you might have thousands of inputs and state management needs, IoT Events can take care of that for you. Then from an IoT Things Graph perspective, IoT Things Graph enables you to abstract the intricacies of different device types and deploy applications both in the cloud and at the edge. So these services have been available for customers for quite some time. But one of the challenges that we hear from customers is how to successfully apply IoT within an industrial environment and to integrate with industrial equipment at scale. To help solve this problem for our customers, we've launched a new service called AWS IoT Sitewise. AWS IoT Sitewise is a managed service that makes it easy to collect, store, organize, and monitor data from industrial equipment at scale. Now, to unlock the full value of IoT data, we need to build capabilities in 5 different pillars. The first is data collection. So before we even make sense of the data, we need an ability to be able to collect it and store it at scale. Next is information modeling, which is an important attribute as it defines the structure of all the information within an IoT system. For example, if you have a virtual entity has an attribute name and a type and one or more values to which it has metadata, such as timestamp, location, so you can associate these critical metadata to that data that's being generated. Next is performance metrics. One of the most critical insights that every organization wants to distill is those key performance and operational metrics that are vital to the business success. So you can focus on understanding and optimizing your operations rather than building costly in-house data collection and management applications. So now that you have ingested the data, you've built some asset models and created performance metrics around that. But as an organization, you don't want to stop there. You want to continuously monitor this data, find anomalies and events, and trigger appropriately actions when those events occur. And finally, you need to run analytics and build reports on top of that data that help solve business problems. So let's now dive a little bit deeper to see how IoT Sitewise helps across each of these 5 core pillars. The first is data collection. So AWS IoT Sitewise can help extract equipment data from databases such as historians, which are commonly found in industrial facilities, and transfer it to the cloud at scale. It natively supports data ingestion through OPC UA and MQTT protocols. Now, ingesting the data through MQTT is very important characteristic of AWS IoT Sitewise. So imagine if you are a producer of a consumer product that is directly ingesting data into IoT Core today. You can leverage the IoT Core rules engine to create an action to ingest these messages into IoT Sitewise. Now from there, you can start to leverage some of the benefits around the information modeling capabilities that IoT Sitewise enables you to do. So now let's take a look at those information modeling capabilities in a little bit more detail. Once you've ingested that data into the cloud, AWS IoT Sitewise helps you build asset models to create virtual representations of your equipment and associate it to those data streams. You can structure the data and make it easily searchable by users and applications through APIs. Next, let's take a look at performance and metrics. Once you've modeled your physical assets, you can quickly compute performance metrics and create fully managed web applications to help analyze equipment data, prevent costly equipment issues, and reduce production inefficiencies. Next, let's take a look at actions. With AWS IoT Sitewise, you can connect the results and then send them to AWS IoT events that helps you easily detect and respond to events. Now, while we see the evolution of IoT being driven by the new sensors, mobile and wireless technologies, the true value of IoT is the analytics and insights being pulled out of the collected data. Now, within AWS IoT Sitewise, we provide out-of-the-box capabilities to build up operational visualization dashboards to enable you to get near real-time visualizations of the last 90 days of data that's being generated. So this enables your operations, your analysts, your managers to really get close to some of the data and those performance metrics that are being generated from your industrial equipment and help them identify and process issues as they come to light. To enable customers to go beyond operational visualizations and unlock the full potential of their data, customers need a data platform to support this, to help them address their challenges and changing business needs. If you think about the predicted growth of data, plus also the diversity of data sets out there, a new approach to allow this flexibility is critically important. Additionally, as customers look to become more data-driven, the need to provide secure access to any number of applications and people will also increase. And a key enabler to help support this is building a data lake. In 2019, AWS launched AWS Lake Formation to make it easy to build a secure data lake on AWS. AWS Lake Formation provides a comprehensive set of integrated tools to enable users to access consistently across many different types of data sets. AWS Lake Formation also provides a simple way to ingest and clean your data, enabling your data engineers to move faster and onboard new data sources. And lastly, Lake Formation provides centralized management and fine-grained permissions to empower you to provide secure access across the business, but also give that unified viewpoint of the data across your organization. So let's now take a look at how we can go about integrating our IoT services into an AWS Data Lake. So first, we start with our IoT services, where we either have an MQTT message that's being sent in, or we have data that's been ingested and stored into AWS IoT Sitewise. From there, we can enable IoT Sitewise to utilize the AWS IoT rules engine to pass our data downstream. Now, I mentioned AWS IoT Analytics earlier. IoT Analytics enables us to process IoT-specific data and enables us to do some prior transformation before storing it within our Amazon S3 Data Lake. What you can also configure to do is if you want to store your raw data in its raw state, then you can also configure services like Amazon Kinesis Data Firehose to also leverage the streaming capabilities and persist that raw data into your AWS Data Lake on Amazon S3. Now, AWS Lake Formation enables us to build up some of those centralized controls and comprehensive viewpoints of our data across our data lake. Within AWS Lake Formation, we can utilize capabilities like AWS Glue crawlers to crawl our data and infer our schema and store that schema in our AWS Glue data catalog to provide that unified viewpoint for all our data that's situated in our data lake. And then from there, we can leverage services like Amazon Redshift, which is our petabyte scale data warehousing platform that enables us to also query both data in our data warehouse alongside data that's situated in our data lake. Additionally, if we're looking to run ad hoc queries, we could look at services like Amazon Athena to run ad hoc SQL queries directly on our data on our SQL within our S3 data lake. Amazon EMR for if you're looking to leverage any of the tools within the Hadoop ecosystem. And plus also if you're looking to dive deeper and gain deeper insights, Amazon SageMaker can also dip into your data lake and extract that data for your data scientists to start to process. So now let's pause from a slide perspective and dive a little bit deeper in stepping you through an industrial use case using AWS IoT Sitewise and step you through how AWS Sitewise can be integrated into the broader analytics ecosystem. Today we are representing a wind farm operator and looking at how IoT can be applied and integrated into an existing industrial environment. Our simple wind farm today consists of 3 wind turbines, with each wind turbine having 2 PLCs associated to it. PLC 1 is emitting data around wind speed, rotor speed, and generator power, and PLC 2 is emitting outside and equipment temperature. So now let's take a look at from an architecture perspective, and in particular, let's focus out at the edge at the moment around our wind farm station. We have our PLCs, which are associated to our wind turbines. Now, these PLCs are emitting their data to our pre-configured OPC-UA environment. Today, we will be utilizing KEP-Server Express as our OPC-UA server. So that's our demo environment, which we'll be integrating into today. Next, I'd like to explore with you on how to integrate this industrial OPUA environment into AWS and enable some near real-time monitoring. So if we jump back to the architecture, the first step we do is we need to deploy what's called a Sitewise collector. Now think of the Sitewise collector as a gateway between OPC-UA and AWS. The Sitewise collector runs natively on IoT Greengrass runtime, where AWS IoT Greengrass extends the AWS to the edge devices so that they can act locally while still using the cloud for management, analytics, and durable storage. We have our broad range of gateway devices that are certified to run Greengrass. So any of these devices that support Greengrass also support Sitewise. So now that we have our gateway, we configure this to communicate to the OPC-UA environment, which will then allow us to move our data into AWS. From here, we can build our information models of our assets, which enable us to use the out-of-the-box visualizations available within AWS IoT Sitewise to establish some quick and easy near real-time monitoring for our plant operators, managers, and analysts. So let's now take a look in a little bit more detail and jump over to the AWS console. So here in the AWS IoT Sitewise console, the first thing I want to draw your attention to is in the top right-hand corner of the screen. Within the Sitewise console, you can spin up a short-lived demo environment within your own AWS account to enable you to get more familiar with the service. But let's get back to the demo and take a look at the gateway collector that we have configured. So on the left-hand side, I'll click on under ingest gateways, where we can see our Sitewise gateway that we have configured. And let's take a look at some of the configuration items. The first is the Greengrass group ID that I have configured. The local endpoint is the IP address of our OPC-UA server that we have deployed within our wind farm station. This is the security configurations that we have configured, and this is effectively the security handshake and configurations between the OPC-UA server and the Sitewise gateway. The last element is our OPC-UA nodes, which are our entities representing our assets. So these are the data channels that Sitewise Collector will send the data through into AWS. So now that we have our data flowing into AWS, the next step is to start to build our information asset models. So asset models drive standardization for your industrial data. An asset model contains a name, a description, asset properties, and asset hierarchy definitions. So let's take a look at what's being configured here today for the demo. So on the left-hand side, under Build, we'll click on Models. And these are the models that we have pre-configured. Now think of models as a template for assets within your environment. And I've pre-configured a few here. So first and foremost, we have our overarching wind farm model, which has a relationship with a wind turbine. So we'll click on the wind turbine, and I'll demonstrate that to you. And then within the wind turbine itself, it has relationships with the lowest denominator or the primitive asset within our environment here today, and that's the PLCs. So if we click on one of these PLC units, we'll start to see some of the various different elements here. So under the measurement definitions, this is where we can start to define some metadata and some semantics around the data streams that's being ingested into AWS Sitewise. So we have our outside and equipment temperatures. We've associated some units for those temperatures and the data types. What you can also do is you can start to build up some metric calculations for that data that's flowing through. So here we have our we're calculating the average equipment temperature and outside temperature on a 15-minute rolling interval. So that's our model templates. The next part we have to do is we need to instantiate these models per asset in our wind farm. So to do that, we go over to the asset section. So here we have our asset library of our wind farm. And so I've pre-created this asset library for us today. So as I start to expand this tree out, we can see those relationships as part of the various different assets within the wind farm environment. So let's now take a look at one of these PLC units and take a look in a little bit more detail about that data that's flowing through. So under measurements, here we have our measurements, so outside and equipment temperatures, our alias, which is part of that OPC UA node of the data that's flowing through, the notification status and topic I'll come back to, but the last field here is the latest value. So this is a 15-second incremental of the latest value that's being flowing into AWS IoT Sitewise. Additionally, let's take a look at the metrics, and we should see similar sort of data feeds here of that metrics calculation of that raw data that's coming through, of that rolling 15-minute average window for both equipment and outside temperature. And this should be updated within a 15-second rolling interval as well. So now that we have our data being collected, ingested, and we've associated some key metadata to the raw data fields, now let's go and configure a real-time dashboard for our plant operators to use. So to do this, I'm going to go back to the left-hand side and click on Monitor Portals, where I've pre-created a portal for us. So this is the link that we will share out to our plant operators, our users of this near real-time dashboard, for which they can start to get some insights around what's happening on that wind farm. So this alleviates the need for having to provide access to the AWS console for end users. So let's go and configure that near real-time dashboard. So here we are within the AWS IoT Sitewise monitor portal. The first thing that we want to do is we want to associate an asset to a project. So to do that, we will just, first of all, let's just take a look at this asset library. And this is very similar to what we've just been looking at earlier within that within the asset configuration element there. But what you'll notice is as I select a PLC unit, we'll actually get the corresponding data feeds that are flowing in through AWS IoT Sitewise. So and this is near real time, so quite quickly and easily you can get a feel for how things are trending from down to the asset level. But what we want to do, as I mentioned, we want to associate this asset to a project, and this will enable us to build up that model for that near real-time dashboard. So here we'll select that at the highest level, the wind farm, and associate it to the Summit online demo and add that asset to the project. So think of a project of a collection of assets relevant to an environment. So for us today, we only have one overarching project asset, and that associates us to a dashboard. So now let's go and configure this dashboard. So this is our wind farm demo dashboard that we're going to start to build some visualizations for. And what I want to do first of all is we want to get a feel for what the correlations are with the power being generated and the overall wind speed from an environmental standpoint. So here we can see as we expand these assets out and the information models that we've built, these fields are being updated as we speak. So we're going to put wind speed and then we'll put generator power and overlay those two metrics together. Generator power. What we'll also do is we'll just drag that across. I'm going to select, change the visualization into bar graph. So you can see there's a number of different simple metrics that you can choose, a line graph and also a KPI as part of that. And then we'll just hit done. And so here's our simple dashboard that we've built in a couple of seconds. And as you can see that the time's being updated here. And as the data is flowing through to IoT Sitewise, this is also being represented. And so from here, we can go and share this out to our users and they can get access to this near real-time data. Very commonly, customers want to build some more advanced monitoring and alerting capabilities. So let's now take a look at how we can extend what we have currently built to include this. By default, IoT Sitewise doesn't emit data outside of the service, but it's easy to configure to allow downstream data flows. Once configured, IoT Sitewise can push the data into an IoT topic where you can configure IoT rules engine to direct data to various IoT services. Services such as IoT Analytics are a key service to enable us to perform some near real-time analytics on the data streams. So say, for example, we can enable IoT Analytics to perform some minor transformations to prepare the data to move into services like AWS IoT Events, where we can perform some near real-time analysis of the state of the data relevant to business metrics and perform an action like sending a notification to our operators via Amazon SNS. So now let's take a look in a little bit more detail and jump back into the console. So here we are within the AWS IoT console. Now, as I mentioned, AWS IoT by default doesn't allow you to move your data downstream for integration purposes. But to enable us to integrate into AWS IoT Core Rules Engine, what we do need to do is we need to modify and adjust the configuration from an asset perspective. So if we jump back into the asset library, let's select PLC Unit 1. And what we need to now think about is what we want to enable from a data stream perspective to be integrated downstream. So if we move over to our measurements and our data feeds that are moving into AWS IoT Sitewise, the key configuration item here is around the notification section. So let's jump into the edit and edit this asset. And you can see here there's a number of different sections here around the notification status being disabled. And so this is the AWS IoT topic that AWS IoT Sitewise publishes each data feed into AWS IoT. So from a measurement perspective, our notification status, I've pre-configured our measurements and our metrics to be published and made available into AWS IoT Core Rules Engine. So you can see here the notification status is set to enabled, and then this is the topic where this data feed for this particular asset will be moved into that topic. So now that we have that, we've got that configured, the next part that I wanted to showcase to you is IoT events. So I mentioned as part of that IoT Core Rules Engine, within our demo, we're integrating into AWS IoT Analytics. I'm not going to show IoT Analytics just at this point in time. We'll come back to that. But what I do want to show you is the state machines and effectively the detector models that you can build within AWS IoT Events. So here within AWS IoT Events, we have what's called a detector model. Now think of a detector model as a model of your equipment or process using state. So here we have configured two types of states. We've got good and critical. And within this state, I've configured some environmental conditions that effectively are looking for and checking the temperature. So checking the average temperature, and if that temperature breaches above 110 degrees Fahrenheit, we will be making a stateful change. Now, if we see three events that make that change, then we'll move the condition from good to critical. And then once we do fall into that critical phase, then this is where you can start to configure notifications that through Amazon SNS that can be pushed down to your plant operators or wind farm operators, and so they can be notified of a critical event. In the final part of the demo today, I want to showcase to you how you can go about integrating AWS IoT Sitewise into an AWS Data Lake. So here we are back to our architecture. And the key service here that's going to enable us to persist our data into Amazon S3 is AWS IoT Analytics. So what we've configured within AWS IoT Analytics is what's called a data store, which is effectively backed by Amazon S3. Now, once we have our data streaming into Amazon S3, we can start to leverage services like AWS Lake Formation that can help us build a data lake in a short period of time, and leveraging services like AWS Glue Crawler, which enables us to crawl our data sets and infer that schema and store that within the AWS Glue data catalog. Now, once that data set is available, has been crawled and the schema has been made available within the data catalog, we can leverage services like Amazon Redshift, Amazon Athena, or even Amazon SageMaker to enable to dip into our data lake, where it enables us to build data models that integrates both operational historic data with the data that's being streamed in from our IoT services and persisted in our data lake, enabling managers and analysts to get to reporting and build self-service data models. So let's now take a look at that in a little bit more detail in the console. So we'll jump back over here. And the first service that I want to showcase to you is AWS IoT Analytics. So think of AWS IoT Analytics as three core components. Our channel, which is where we're pulling our messages from. Today, that's IoT Core, because that's what we've configured as part of AWS Sitewise and within those assets. Pipelines, which is where we can perform some filtering, some transformation and enrichment of the messages, and then data stores. The service feature that I want to showcase to you today in particular is pipelines. So pipelines, what we have configured today is we've configured a simple Lambda function that's performing some light transformation on the data. Effectively what it's doing is flattening the JSON document or message that's being emitted through via AWS Sitewise. So this is the raw AWS Sitewise message that gets pushed downstream into the IoT core rules engine. You can see our value from our asset here. And I'll showcase to you just the output from that Lambda function. So if we move over to that Lambda function here, we can see the incoming message. And then if I just reduce this batch size to 1 and we just do an update, you can see the output of that message here. So we're effectively flattening that JSON document into a simple JSON file, which is going to make it easier for us to use SQL queries against this data set downstream. So now that we have that data being transformed, the last part within IoT Analytics that I want to showcase to you is that data store. And that's effectively our data lake that we have configured. So if we move over to our data stores here, and as we have defined, we've got our S3 bucket, which is our data lake. And so from here, we've configured AWS Lake Formation and AWS Glue to be able to crawl that data set and infer that schema. So similar to what you saw within AWS IoT Analytics, this is the schema that's been inferred by our Glue crawlers. So we have our S3 location where the data is being stored. We have a number of records that are part of that location here. But this is the schema and similar to that output for that Lambda function, which is enabling us to now be able to build SQL queries and be able to query that language, which for us, we can start to leverage the power of Redshift Spectrum, and that Lakehouse architecture methodology to be able to bring together business insights and also this IoT data set to start to build some informational dashboards. And so what I have built today as an example is a dashboard that's representing both forecast data and actual real-time streaming data of power being generated. So think of the forecast data that's being generated over many years of historical data that we've stored, and our data scientists and our analytics team have built up, our forecasting team have built up. And then what we've been able to do, we can leverage Redshift Spectrum to overlay and query the IoT data that's coming into our platform here. And so you can quite easily start to build up some and get a quick reference on what we're generating versus forecast, how our wind turbines are performing here, what's that KPI against that summary of that bar graph over there, and then also some simple line graphs of the power actually being generated real time and that wind speed. So that completes the demo. Let's now jump back to the slides. So when customers start to embark on an IoT project, they often ask me, well, what does good look like? Where should I start? And what are the key things I should be thinking about? Well, the most important thing I encourage customers to be mindful of is to be really crystal clear on the business problem that you're trying to solve. Nobody buys IoT. They seek business outcomes, and they seek those outcomes from the data that's being generated and those derived insights. So if you think back to those 5 pillars I spoke about before the demo, each of these capabilities builds value from the data being collected all the way to those insights and actions being generated. Now, if you think about these 5 pillars, within each capability, I strongly advise you to dive deep into each of these to ensure a successful outcome for your IoT project. Think about the environment you're embedding and integrating into, like the sensors, protocols, and the overall life cycling of those devices. End-to-end security should be a part of your early conversations. Now, AWS provides services within our IoT platform, but also broader within the IoT ecosystem to help make this easier for you. Consider your information and your data models and how you're going to store this and make this available to your users. Spend time defining those right metrics, both at a business and also at a technology level, which will lead to making the actions more clearer to you. And lastly, think about how you're going to be storing the data, decoupling and being flexible so to ensure that your data platform will be future protected as your use cases change and adapt based on your business needs. So that almost concludes the session today. But before you go, I just wanted to draw your attention to a couple of key learning resources. The first is our free digital online courses available at aws.training. Now here you can find a number of different online digital training courses to help uplift your skills. The second, if you're looking to understand what other customers are doing in the IoT space, then why don't you check out our customer reference page available here. Additionally, if you're looking to get some hands-on experience, first, if you're looking to spin up a very similar demo to what we've stepped through today within the session, then head over to AWS IoT Sitewise console to spin up that demo. Just bear in mind there will be a small cost of approximately $1.50 USD for that entire 7-day period that the demo is operating within your AWS account. And secondly, if you're interested in understanding what devices we've worked with our technology partners around in understanding the support aspect for AWS Greengrass and also Sitewise Collector, then head over to our AWS Partner Device Catalog to understand more. And thanks again for attending. We really appreciate your feedback so we can better understand what topics and services you would like to know more about in the future. So please do take the time to fill out that survey and let us know what you think. Thanks again.